All right. So where we left off was we have defined a query, we have defined a custom type, and we tried to hit that query from a GraphQL ID, and then we got the data from the database by setting up our models and the database connection as well, right? So we have our basic query setup. Now the next part that we will do is create a mutation operation, right? Let's do that now. Let's just close the database feedback. Let's open keep the query. Yep. Now the first thing I have to do within operations is create the mutation.js. So within query, we had one single operation which was feedback list, which gets you the entire list of feedbacks, right? Now within mutation, let's expose the string again. This one will be type mutation, and within this, let's have operations like you can vote up, you can vote down, and you can add a feedback, right? So let's define those. You will have add feedback, you will have vote up, you will have vote down. So each of these will now receive arguments, right? So if you have to add a feedback, you have to get a list of fields from the user and then add that to the database. So let's create this list of fields. So one is the description of the feedback, right? The other is from who are we getting the feedback, the name of the person, email, the phone number, right? So description, the kind of, so these are not the fields that we have defined in our types, these are the arguments that you are getting, right? So we'll have to define the types of the arguments that you receive. So description will be a required string, from will be a required string, email will be a required string, and phone will be a string type, but it's optional, right? And the other type, the other field that we had was upvotes and downvotes. So if you don't pass this, we have already defined in our model that it will be 0 by default. So let's keep it as 0. Now this is the list of arguments that we receive in the operation, and when it's successful, what it will return is a feedback type. So once the data is added to the database, it returns back with the data that was added. For vote up and vote down, what do you think the arguments should be? ID, right? That is our primary key and the unique identifier, which will help us identify the field and the where we need to increase the upvotes and where we need to increase the downvotes. So let's get the ID, which is an int in our case, return back the feedback type, vote down again int, and returns back the feedback when successful, right? So this is about defining the types of operations. Now let's get the resolvers as well. So before that, let's add mutations to our schema. And then with query, we add the mutation as well, right? But in resolvers, we don't have any resolver for our mutations yet. Let's go back to our resolvers folder, add a folder called mutation, add a file called index.js, which contains a list of mutations and returns an object. And we'll have to add it to the parent resolvers list. Right? So inside mutation, what is our first operation within schema? Add feedback, right? We have add feedback, we have vote up, and we have vote down. So we have 3 files we have to create. So let's start with add feedback. Again, we have to get the model so that we can perform the operations on the database. We have to export a function which will do this now. Again, we have to do database operations here, like we have to now do a create operation, right? Again, it's an async operation. So let's have functions defined async by default. And what we have to wait for is feedback dot create, right? So within this create, I have to fetch the arguments and now pass it to the create operation, right? So what you receive in the resolver itself is you receive the parent, you receive the arguments, you receive the context, and you receive the info. So all that we need here, so this is the parent resolved data. So if this particular field has a parent resolver as well, so whatever returns from the parent resolver is passed to the child resolvers. And we get the list of arguments. Whenever we call, we pass the list of arguments. That is what comes in the arguments array. Next is the context. So when you are defining your schema, right? Instead of creating an executable schema and getting the feedback in each case, what we can do is we can also pass a context object here in this executable, and then that goes to all your resolvers, right? So that is something which is available in the context object, and info is the data that you use for introspection within that. So if you have a list of fields, you want to get the list of fields from here. So there is a helper called GraphQL list fields, which is a separate NPM module. So it helps you get all the fields that have been requested for, and then do your processing based on the same. So those are not something we are working on right now. So let's just get the arguments. We deconstruct it, right? So who is aware of this spread operation here? So whatever fields you are receiving the arguments, you are directly putting it as part of the new object, right? And if you want to modify any, like I know that phone can be a null, so I want to specifically pass null to the database. So what I can do is I can override the arguments, and then I'll check for args.phone. If it's not present, I'll just specifically pass null, right? Oh, sorry. Yep. Cool. So whatever arguments I receive, I'm calling feedback.create. I'm waiting for the operation to complete, and whatever is returned from here, I return back. So I'm creating a new set in the database itself, and I'm returning that when I'm calling this. So let's try it out. So I have a mutation. I have to also export it. Import add feedback /add feedback. Cool. And I send it back inside the mutation, and within the mutation, I'm sending that to the parent resolvers. So my resolvers has now resolver both for query and mutations. And we already modified the schema.js towards the beginning, where all the operations from the mutation query is also part of the root query now. So this root query is part of the type definitions. Let's try it out. Now instead of a simple query, what I can do is I can do a mutation query. I call it add feedback mutation. Call the, I have to refresh. So I have to refresh because it has to do the introspection again to give me the autocomplete for the new resolvers that I've added. So this add feedback is expecting a lot of fields, and in return it's giving me feedback. So whenever it's created, I want ID from an email back. So when I'm creating this, I pass the description, testing 1 2 3. I pass the from. I pass some name like Sanjay, and I send the email, right? Sanjay@sapient.com, right? So these are the arguments I am sending to my mutation. So I want these fields to be added to the database, and then when I am getting back the response, I want these fields returned back, right? Let's try that. So I got the data back. So has my data been added? Let's check. So you can see this query, right? This is what SQLize is performing. It's inserting into the database. Now let's check our database. So we have this field added to our database, right? Any doubts on mutations? It's the same exact way that you write a query resolver. For the mutations, what you get is a list of arguments. You use those arguments and then do your database operation or any other async operation. So one of the questions that I received during the break was, can you do other operations as well apart from database? So you can do any kind of async operation here, which can be even be an external API call. You can do orchestration over multiple APIs and then return back the data that is conforming with the types that you have defined, right? So you can do any kind of async operation here, not just database operations. Cool. So let's add a couple of more mutations here, like voteup.js and votedown.js. So you're tired of writing this. I'll get the model in both the cases, right? And standard, I have to, I better start writing async on begin because I have to do async operations here, right? So what do I have to do in this case? I'll get an ID from the query and I have to go and increase the upvotes of that particular row, right? So let's start with that. So we called feedback.update. So what we can do simply is we know the field name and we know the operation that we have to perform. We have to increment it, right? So we can use a special help from SQLize. I have to increase the upvotes, and I do this by doing SQLize.literal upvotes plus 1. So this expression is evaluated and stored. So upvotes is getting from the database, it's incrementing it and updating my upvotes field, right? And when do I want to do it? Where I get the ID. So I have to fetch this ID from the arguments, right? So I get the parent and I get the arguments. So instead of fetching the entire arguments, let's deconstruct and get just the ID from here, right? We get the ID, we pass it to the query. So what we have done is wait for the update operation to happen. Now what I am returning is the entire feedback row, right? So this update operation does not return me, it just returns me the updated field. So let's wait for another update. We get feedback.findById and passes the ID. So we'll return the entire row once it's updated, right? So this code is having its execution asynchronously, but it looks like it's a synchronous operation that you're doing, right? So let's do the same for vote down as well. So instead of upwards, I have to increase the downwards, and basically the same operation, right? Cool. So inside index, let's get these two operations in. Vote up, expose the vote down. And in the schema, we already have the types defined. What are the operations and what are the return types? So let's try one of them. So I'll have a mutation called vote up operation, and I have to refresh this because I'll not get introspection. A vote up operation. So I need to know some IDs, right? So suppose let's get this particular ID. ID as 14, and then once the response comes, get from description ID and the upwards, right? So if I hit it, I have a upward of 1, which by default was, when I initialized it, it was 0. So if I continue executing it, you can see that the upwards are increasing, right? If you're not able to see it, this field, it keeps increasing when you do that, right? Get a question? Yeah. Tell me. Yeah, you can, but then that has to be part of your schema then. So if there is a generic error, there is a field called error in the GraphQL response which contains whatever error happened on the back end, right? But then if you have to define your own custom, that has to be part of your schema, so that GraphQL knows that this is what you're exposing in that particular schema. So let's do the same with vote down. And I'll do the same. Sequelize is not defined. See, this is the kind of message that you get when there is an error on the back end. So it gives me an errors object and then errors array inside which you have a message called sequelize is not defined. Now let's go back and see what went wrong. So inside vote down, I haven't imported sequelize, but I have used sequelize here, right? Because I copy pasted the rest of the code. Right? So now it's not doing anything. Oh, yes, I'm getting the upwards. Damn it. So I have to get the downwards in this case. Right? My downwards are increasing whenever I'm doing a vote down. Cool? So we have set up an entire, just a minute. So we have set up an entire setup where we can query for the data, we can add to it, we can modify some of the part of this data, right? Either you can hit an API call or you can use a database operation like we are doing right now. So this is the entire server side setup that we'll have. Yep.
The return that you written is that dot find by.
Huh.
Is that a sequelizer function or the resolver one?
This is the sequelize function. So I'm doing it on the feedback model, right? So feedback model is from sequelize.
Does that mean it returns the raw data from the database?
Yep. So it will exactly return all the fields that are there in the database. So in the database, I have kept the name same as what we have. So if you go look at the structure, right? So we have the same names, which are mapping to my GraphQL types. So that is what it's doing. It's getting the field by ID and then returning the entire object. So like this, you have a lot of functions actually. If I just do an autocomplete, right? So these are all sequelize methods, which you can execute on the. Sorry, I'm not able to. Can someone?
Did we write one resolver for find out, or did we write in query?
No. So what I am done, let me show you that. In the schema, what you have done is, in the vote up operation, I said that I'll send back a feedback type, right? So this is what I'm trying to send back, so that from this feedback, the user can fetch any data that he wants, like ID or email or phone, whatever you want for the client. After updating it, you get that data from the particular feedback type, right? Everyone is clear with this? Cool. So I guess some of you have this feeling right now that you understand what GraphQL is doing behind the scenes to get to have resolvers get the data for you, right? Now doing some integration of React plus GraphQL, right? So we won't be going into details. Yeah, go.
Like as you had said in your earlier slide that we should, when we develop a GraphQL, right, so, we should think in terms of graph connectivity.
Hmm.
Now, let's say this is like we are fetching from one database,
Hmm.
and suppose we have like some data coming from a database, some from an REST endpoint or
Hmm.
something.
Hmm.
Now we need to collate that data and show it to send it to to the client.
Right.
So does GraphQL provide some kind of joins or something? How do we think?
GraphQL does not do the joins. GraphQL, you are having a resolver function inside which you can have multiple promises. Each of those promises can hit the independent data sources. Once they return back, you can collate the entire data and then send it back.
So essentially what it means is that our schema when we design should be in terms of that connecting the dots.
Exactly. Your schema design should be so well defined in terms of your data that is exposed that the clients can use any subset of that information that they want. So you can have different models, you can have different entities involved, and then they can merge and join the way they want. So the person who is defining the schema has to think in terms of what all can be the combinations that the clients can use, right? That's why it's important to have a client to start off with.
Okay, so
Yeah, go ahead.
so like what are the good practices or the right ways to define schema? Because like in suppose like if I see in terms of database developers,
Hmm.
they are specialist data designers.
Hmm.
Do we require some kind of a knowledge in terms of that also so as to
Definitely not. But you need to have knowledge of what all are the entities involved. So what all are the kind of data, what all are the relations that are there between different entities. That kind of knowledge you need to have, because the people who are designing are the actual database folks and the service folks who are exposing the data instead of catering to a particular view. So when they are designing for the data, they don't have any idea of what the view might be, because it can be a different device, it can be a different client, and they might have a different kind of a requirement, right? But my API should be such that it's able to cater to all those information and they can structure and get it in the way they want. So I should not have a view in mind when I'm defining my schemas. Cool. All right. So people who have basic experience with React. There is only one hand. So everyone has heard about React at least, right? Or no one has even heard about React? Raise of hands. Okay, cool. That helps, because I'm not going into details into how React works. So I'll be showing how to do this in React so that you can take this forward with any other framework. It's not specific to React itself, but that you have libraries available for Angular. You have an independent Apollo fetch library which fetches your GraphQL endpoint data. So you have your implementation is independent of what your framework is. So if I have to quickly talk about React.js in 2 minutes, so what is it? So it's a library for creating user interfaces, right? So it lets you define your views, it lets you define components, it renders a UI, it responds to events, and you can compose different components to form a single component. So you can have consolidated views, you can have atomic views with React, as simple as that. I'll show when we are breaking our HTML into React components, I'll show you how to do that. One of the basic functionalities which React has is virtual DOM, because what React suggests is whenever there is any change in state, re-render the data, right? So your props, you are getting your data through props in React, and whenever there is a change, you re-render the data, and then React takes care of the re-render for you by optimizing your re-renders with only the changes that are there in the DOM by diffing it using virtual DOM. So that is one of the operations which is extremely optimized in React. Now, when Facebook released React, so one of the first reactions that it had was rethink established best practices. So we had a different HTML, we had a different JS, we had a different CSS, and when React showed the patterns that that was involved, it had one single file which had your JS logic and your HTML inside it, right? It looks like an anti-pattern when you start off, but then when you are developing your components, it's actually very intuitive because all the logic of your components lies within the same file, and you know how your view is updating based on what are the changes in the data, right? So let's start breaking down an application. So to show you what we are trying to build, so this is the kind of application we are trying to build where we can like the data, and we can also have something called the submit. I'll just add and then it gets added to the original view, right? Cool. Let's start breaking down an application. So if I have to go back, so this is the basic setup that is provided by Facebook's Create React app. So that is a CLI. So you can initialize the application, React application using Create React app with zero configuration. So you don't have to worry about what is the Webpack setup, what is the build setup, how will it break it down to different files. You don't have to worry about all that. All you have to do is initialize the application, and it comes with a basic setup. So inside the basic setup, you have a bunch of packages, but then all the primary React libraries are already in part of it. And if you want to add anything on top, you add that using yarn add package name, right? The HTML that we are going to build, I've already kept that aside so that we can break the same into components instead of focusing on HTML CSS throughout the entire session. And inside SRC, we have the test folder, we have the components folder, we have the CSS file, we have the index.js file, all this provided out of the box when you're doing a Create React app. So inside index.js, I'm rendering a single application, and that component is within SRC components, and what we're doing is just returning an h1 which says hello, right? Now let's start. If you do yarn start, we get hello, we start here, right? So to simply show you the component setup, there are different ways in you can define a component. This is a class way of doing it, where you extend react.component and you provide a render method and you return your view from it, right? Now instead of doing this, you can also have a stateless component where you are just having a function which takes in props and then returns a view. But instead of going that, let's try to break components and show you in practical life how you will go about it. So index.ref.html has the base markup for the list that I have, and we'll try to break it down into different components and create the stateless and stateful components from there. So let's take the entire HTML and paste it here, right? So I have some feedback, my name here, like dislike as 0, and I have this static view, right? Let's further break it down now. Now let's take out the entire list part and put it in the different file, something called feedback list.js. So let's import React here, and then let's create a feedback list function which takes in props and enters the. This is just static breakdown. There is no dynamic data involved yet. Okay. Now, this particular part of my application has to be repeated, right? So, this is one single item within a list of items. So, let's break it down into a different component. Feedback item.js. We import React. And then create feedback item which takes in props again, and then return this list item. So let's export the. So this is our one single item, the smallest component that we will have right now. Now let's go back to the feedback list, get this feedback item, and paste the feedback item here, and then within my app I should have the feedback list. Oh, I didn't export the feedback. Right? So I've broken that one single view into different components. I have a list of feedbacks, which is one component, and within that I have a single item, which is one single feedback. Right? All as static as of now. There is nothing dynamic about it. So what if I have to make this particular, this is the smallest component that we have as of now, right? So if you have to make the data as dynamic, we have to accept some data as part of the, whenever the component is inserted somewhere, right? So that is what is called as props. So let's accept some props like details, which needs to be a basically all the name and feedback and description, all those details should be part of this particular object. But before that, let's try to have some mock data. So if I have an object whose ID is 1, description is test, I have from defined as my name, and I also have the upwards as 4, downwards as 3, and let's have two sets of data here. Test 2, Sanjay, 3, 5, right? So based on this data set, I need to iterate over it and create multiple items, right? Let's do that. Now what we'll do here is data, this is an array, right? Array of objects. So let's use the map operation on this. Get the single feedback item. So this is my function which will get each feedback item and apply its transformations, and finally return a new array based on the transformation I am doing. So from this particular feedback item, what I have to do is I have to return the new component mapped to this. right? And if I have to pass the details, I'll pass this single feedback that I'm receiving as part of the map function, right? And also when you're iterating over it, you have to provide a unique key to each of these items so that React can identify and then modify that particular item of the entire DOM so that there is a diff and only that particular element gets updated. So you have to provide a key, which will be again, let's make it feedback of .id for now. So what you're doing is you're going through the entire data array and corresponding to each object that you have, you're creating a feedback item component now, right? And you're passing that feedback to the details property, right? Now inside this, I'll receive it in props. So let's replace it with props.description, props.from, props.upvotes, and props. Sorry, I'll getting it within a details. There's a details prop within the props that I'm receiving. Right? So the smallest component that we have right now is dynamic. It's changing data based on the props that I'm sending. So let's see. Oh, yeah. Right? Now based on the data, I'm iterating over it and creating the small components. Let's go back to the feedback list. Now what do I have to do? I have to replace this particular data with the response from the server, right? So let's try to do that now. Let's remove the entire data. And before we try to get the data from the server, we need to set it up in index.js. So even before that, there was, if you look at the entire application, we had one where we had the views and one where we have the form where we are submitting the data. So let's try to incorporate that as well before linking it. Let's keep this mock data. Let's create a new file called feedback form. We import React and again feedback form, which gets props and then returns a DOM. So if I go to index.ref.html again, I have the DOM for the entire form in place here, right? And export out this component. And inside app, now I have to get the feedback form as well. Now let's add that before feedback list. Right, so we have the form and we have the list of data. Now these two have to be segregated based on routes, right? So if I hit /submit, I have to see the form, and if I hit the index route, I have to see the list. So how do I do that? So to do that, we need to incorporate the React router integration where we have the browser router integrated into the browser history. So whenever there is a change to the route, it has to be communicated to the browser router. So if I try to get the browser router here, so there is a higher order component exposed from React router, basically the React router DOM package. Called browser router, and this has to wrap my original application. Right? So by wrapping my original application on with browser router, now I'm enabling client-side routing, right? So all of the routes will be available now. The entire history API will be available to the props. And if I go to my application, I'll have to define my routes. So I'll get from the same React router DOM package, I'll get the higher order components called switch and route. Now instead of putting both the components here, now I have to define my routes within the component. So in React Router DOM, React Router 4, what they have changed is basically instead of one single place where you are setting up the entire routes, what you have is within the components you can define the routes, and then based on this route, which component to hit is something you can define. So inside switch, I have a route, and I say I need an exact match to the path slash, and on path slash it will load the component feedback list, right? So when I hit slash, it will load my feedback list component, and I hit slash submit, it should load the feedback form component, right? Simple setup. Let's try it out. So I am already on my slash route where it's only loading the feedback list, and now if I go to slash submit, it will show me the form. Now let's try to make it dynamic. So what you have to do here is that the initial library that we used for Express was Apollo Server Express, which gave you the helpers for all the routes that you're defining for graphical and GraphQL routes as well. Now for React, they have a library called React Apollo, which gives you higher order components like Apollo Provider, to which you can pass the client which has the interface configuration for the network requests. So every request that goes through from your components will be going through one single endpoint which you will be defining in your higher order component. So let's get that from the helpers. So you have to import a bunch of things from React Apollo. So the first thing will be Apollo client, which has your network configurations. Then there is Apollo provider, which is your higher order component on top of your application, and then a helper to create the network interface in which you provide the endpoints, right? So we have to wrap our app with the Apollo provider higher order component. And to this Apollo provider, we have to pass the client that it will be using for all the requests that are outgoing. So let's define that client. It will be a new instance of the Apollo client in which the configuration that it expects is a network interface in which you provide the URI which you will be hitting. So even before that, now let's create a network interface. To which you're getting passing a URI. Now this URI is one single URI for GraphQL. So every request will be going through the same URI for all the operations that you have. So let's have it as, so we created a server on port 9999, right? And slash GraphQL, right? And then we have to pass this network interface to the client, and then this client to the higher order component, right? So this is the basic setup to enable your components to hit the GraphQL endpoint, right? Let's go ahead. Let's go to the feedback list. Now remove this entire mock data, right? Now we have to get a couple of higher order components on top of feedback list as well, so that they can hit a particular query. So there is one. So from React Apollo, I'll have to import. One is the GraphQL higher order, and the other is the GQL helper, which takes your if you have to define your queries within the application, you define it as a string, you pass it to GQL to make it an actual data object, JSON object, which will be sent to your network request, through your network request. So let's define the query we want to hit for this particular list. So it will be a query called all feedbacks query, and within that I have to hit feedback list. So if you can go back to your server and look at your schema. So this is what I have to hit to get the list of feedbacks, right? So within feedback list, what are the things that I need? I need the description, I need from, I need upwards, I need downwards, right? 4 properties. I don't need the entire data set of email and phone number and everything. So I'll just request for what I need. So I'll get the ID for the key, description, from, upwards, and downwards, right? So this is my query. Now I have to use this query and create a request, for which I have to use the GraphQL higher order. So one is the GraphQL helper, to which you have to pass this all feedbacks query, and then what returns is the actual decorator on top of your component, which enables your which adds to the props of your feedback list. So all feedbacks query, you have defined a query, you need a feedback list with the list of items that you have defined. Now we have to replace this with what you return from, what you get from the props. So if I simply console.log what I am getting in props, node, GraphQL tag. Oh, damn it. I didn't use the GQL. So I passed it string directly. So what this GQL is a tag template literal now. So this particular query goes into your GQL function, it processes it, creates an object, and that goes into your GraphQL call. So you don't pass a simple string, you pass the actual schema that you are calling. So this is the same that you are doing in the server-side implementation as well, where you are defining it as strings and then you are changing it into a schema using make executable schema. So here you have to use a GQL helper. So if I look at my console, yeah, it gave me a network error. Now let's look at that. So it tried to hit GraphQL. So the configuration is there. Can you tell me why it gave me 405 method not allowed? I have not enabled cross origin on my server. So only accepting requests from the same endpoint. Let's do that. We can do that with a simple module. called cars, and I'll enable it on all the routes for now. Right, so my server has restarted, I guess. Yeah, let's try to hit it again. So this time it gave me a 200 OK since I have enabled cars. Right, so if I go back to my console, what I'm getting is a data. I have history from my route, I have location from my browser router, and I have data. So this is the object which is returned from the GraphQL query, and I am getting the loading as true, and then after some time I am getting the loading as false when I have the feedback list inside it, right? So the initial request goes, and it has the loading as true till the time it has the actual data. So let's put a condition. If props.data.loading, just return a p tag which has loading inside it, right? Otherwise, go ahead and render the entire DOM, right? Till the time the loading flag is true, don't do anything. And in this place, instead of props.data, what you have to use is props.data. There is a feedback list. So whatever you request inside it, you get the same response. So you have a field called feedback list. Right? So we have mapped it to the original array that we are receiving, and while the loading flag is true, we are sending it loading, right? So you can quickly see, it comes loading initially, and then once the data is loaded, it sends you the exact data that you have in the database, right? Simple to set up. Any doubts till now? Any doubts? Because yeah, go ahead.
Sending two requests to get this loading state first. Sending two requests to get loading state first, and then the actual state, or resolving that twice and sending the response to that.
So you have to control your rendering. So it sends two requests. So initial request, it's fetching the data, and it tells you that the loading flag is true. And during that operation, if you want to show a different view, you can use that now. So till the request is complete. The request is initiated, it tells you, it starts rendering. If you have to show an alternate view there, you can do that using this flag. Otherwise, you can just wait for the initial data to load. Cool? So I have used my query here. Now what is remaining? I have my feedback item, I have my feedback form. So inside my feedback item, I have two links here, like and dislike. So when I click on it, I have to increase the upwards or increase the downwards. Even before that, let's use a feedback form so that we can do the add feedback mutation here. So again, similar to feedback list, we'll have to get the GraphQL and GQL helper. You have to define your mutation. You have to use it as a tag literal and define your mutation operation as add feedback operation, in which you'll have to pass a set of arguments. Within this, it will go to the add feedback where you have to pass those arguments, and then whatever comes back, you have to map it to the view, right? So maybe I don't want to do anything, I'll just fetch the ID and return back. What I have to pass to it is basically description from email, phone, right? And the types of these have to be defined on the parent. So this is validation at the client level. So your description is a string, your from is a string, again required, and a string. And these fields that you have will be received from the parent query itself. The description, let's add a dollar so differentiated. Description will be dollar description. Your from will be dollar from. Your email will be dollar email. Your phone will be dollar phone, right? So this is my mutation query. So I have to also send the request from here. So the first step again, let's keep the feedback form aside. So since I have multiple operations, I can nest them one inside the other. So let's have the vote up operation first. Oh, it's not vote up, it's add feedback operation. Simple, it's just one in this case. So pass the feedback form to it, right? And let's just name the operation as well, so that you can reference it using that in our handlers. So whenever there is a submit action, I have to call this particular query, right? So let's get something called add feedback action in the props, which does this for me, right? So inside my props, I'll have an operation called add feedback action, and I can use that to trigger this query. So within this form, I have 4 fields: name, phone, email, and description. And I have to reference each of these. I get a reference of each of these inputs so that I can fetch them and send it to the query, right? So let's get a bunch of refs defined, which is called name input, phone input, email input, and a description text area, right? So I've got a description area. So inside each of these inputs or text areas, you can have a field called ref, which basically gives you a function inside which you get the reference of the DOM element, right? I'll get a reference of the input, and I just store it within name input, right? Let's do that for the rest as well. For phone, I'll have something called phone input. For email, I'll have an email input, and for description, I'll have a description area. So instead of name here, it's description area. So I have reference of all my inputs within this component, right? Now let's attach synthetic event, which is on submit. I'll have a function called help submit event. Let me just define that outside. Submit event, which will get the event reference, and what I have to do here is I have to get the details from the form, and I have to trigger this particular action, right? So let's get that arguments as variables. So let's create the variables from here, and before that, I'll just prevent the default action of the DOM. I'll need to send these 4 variables, right? Description, from, email, and phone. So I'll get the description from description area.value. I'll get the from name input.value. I'll get the email from email input.value. I'll get the phone for phone input dot value. Right? So I have the list of variables that need to change for this query. Now what I have to do here is within props, I'll get a method that I have defined below called add feedback action. This mutation is coming in the name of add feedback action because that is what I gave it to the name argument of this. Props.add feedback action, and within that I have to send the variables, right? So again, this action is an async action, so I can make my method as async and wait for this operation to complete, right? I'll wait for the mutation operation to complete, and then once it's complete, I have to send it back to the original page, which contains the list of all my feedbacks. So I'll just say props dot history dot push slash. So once I have added the data and it has come back with a response, I do a props dot history dot push to the original page. Okay, let's try it out. Oh, failed to compile. Expected use of name. Does it have a global? Let's look at the network. Oh, does it have a name? Which doesn't have a name? Name description, name value. So what am I passing here? Let me take out the Tom and check. There's nothing within my Tom. Import. Type text, name description, ID text. So what is my query that I'm sending? Mutation query has description from email and phone. Oh, damn. This one would have been a difficult one to catch. Cool. So if I go to my submit, I fill my name, I give different email ID, test, command, insert, and let's monitor the network as well. So it did the insert, right? Because it came back and went to the original list page with the new entry, right? Everyone clear till now? Any questions? Sure you have questions. Because this is just one of the operations that you can perform. Now can someone tell me what will I have to do for vote up? Anyone wants to give a try? What is the first step that I have to do within feedback item? I have to create the query, right? Whatever query I have to hit. So if I go back to my feedback item, so on click of this particular link, I have to call the event handler, right? I'll define my query like I did for, so just for lack of time, I'm just trying to explain because I have to write the code again. So we are falling short of time. So if you want me to write the code, I'll write the code. but then I'm explaining what you have to do. The same mutation that you had. So instead of add feedback operation, you'll have a vote up operation where you will be passing an ID, which will be defined as an integer. You'll have to send that to vote up, because vote up is the name of the mutation that we have defined on the server. Pass it the ID and then get the response, right? So you'll have the event handlers on this particular on these particular links. You have on click. You'll have to have an event handler. Within that event handler, you'll get props.details.id. You will send it to the vote up action that you assign to it, right? And once you receive it, you have to refetch the data again to refresh the entire view, right? Anyone needs clarity on this particular font? Tell me.
Can't we do something like why do we have to refresh the whole list to
Or we can just return and then you have to do the manipulation. I'm just giving you the vanilla scenario where you are doing multiple operations and you do the refetch. Or you'll have to modify the existing data that you have. That is also in store. So Apollo in the internals, it uses Redux for doing its state management. So all the previous queries are stored in an object called previous. So all your subscription data and everything else is stored in that itself. Right? Cool. Let's go back. So what we have done here is we have created a server with GraphQL which can respond to GraphQL queries, and we have created a client through which we can hit the GraphQL APIs and get the data and render our application. Right? Cool. So do you think this particular setup is powerful in terms of getting data and fetching data instead of the service deciding what data you need, right? Don't you think this entire concept is more powerful than that, right? And on a similar note that I end with each and every slide, with great power comes great enjoyment, yes, for sure, but be responsible with it, because the way you implement your resolvers will determine the performance of the application, how the data is being fetched back. There has to be proper error handling. We have not done error handling at all in our application. We have just fetched the data and then changed the routes and then refetched the data, but then we have not done error handling. So proper error handling measures need to be in place, and that needs to be part of your schema as well. So yeah, that's all I have to show for today. Thank you. Any questions?